guys, today we're going to look at factoring some more trinomials, this time some that are a little special because they have no b value. So factoring quadratics continued is what we're going to do. This week, I just want you to really focus on nailing quad factoring. It's an important skill. You'll use it on the ACT. You'll use it in Algebra 3 and college algebra. And so just really hone that skill this week. And that'll let everybody get caught up that maybe didn't have access or is kind of working from home on a different route. So just keep working, keep plugging away. Shoot me questions through Canvas or email if you have them, or Remind even works as well, okay? And so let's look at these that have no b value. So x squared minus 16. So we're going to factor this. So there's no b value, right? There's no x term, and so it's a little different, but it works the same. I can do this the same way. Initially, anyway, we're going to look at kind of what happens. So some really cool things happen. So my a is 1, my b is 0, and my c is negative 16. So if I multiply a times c, 1 times negative 16, I get negative 16. And I want factors of negative 16 that add to 0. Okay, so negative 16, that means my numbers have to, one be positive, one be negative, and I have to zero out. Well, if I'm adding two things together and they zero, well, that means they're going to be additive inverses. That goes all the way back to like Algebra 1. You guys talked about additive inverses, right? And so remember, there are two things that add to be 0. Well, when I add them and they're 0, that means one's positive, one's negative, and they're the same number. So 16, the numbers that multiply to 16 are 4 and 4 that are the same, but one of them's negative, right? So negative 4 and 4. Remember, we divided by a. Well, the a value is 1, so if I divide by 1, that's kind of silly. It doesn't really change anything. And so I get x minus 4, x plus 4. Well, that's kind of cool. And so let's look at another one. Let's see what happens. So those are kind of interesting in the form that they are. Let's look at one that has a different number for my a value. So I got a equals 1, b equals 0, c equals negative 9. So same thing, 4 times negative 9 is negative 36. So I want factors of negative 36 that add to be 0. Okay, so a number that multiplies to 36, that's the same number, 6 times 6. And if one of them is negative and I add them, negative 6 plus 6 is 0, right? So negative 6 and 6. Remember, we're going to divide by the a value because we multiplied it in. I got to divide it back out. Nope, that a value is 4 over. I don't know why I wrote 1 over there. Sorry if any of that confused anybody. That a value should have been 4. Obviously, I used it as here, but I just wrote it as a 1 instead of a 4. I apologize. All right, remember, you're going to simplify these fractions, and so that's going to be negative 3 halves. Nope. Yes. And positive 3 halves. All right, and then this is where we got to remember to do bottoms up. All right, raise it in the air. Check it like you just don't care. Okay. So we're going to take these and they're going to come up, right? So you're going to get 2x minus 3 and 2x plus 3. Okay. All right. So I'm noticing that my pieces are the same so far except for a sign in the middle. That's kind of cool. Let me tell you the factors of a few more. So we've said if I factored, so let's kind of think about this for a second. So I said x squared minus 16, we factored that to x minus 4, x plus 4. We factored 4x squared minus 9, and that gives me 2x minus 3 and 2x plus 3. I'm going to tell you a couple of other ones that factor. If you were to factor 9x squared minus 1, that's going to be 3x minus 1, 3x plus 1. 25x squared minus 4, that's 5x minus 2, 5x plus 2. Every single one of these, notice that the first term and the first parenthesis and the second parenthesis are identical except for the sign change, right? And so it turns out that there's a little rule for factoring these, because I'm going to tell you right now, if I were to factor one that was really, really big by hand, then it would look really messy, all right? The other thing that I noticed is that there's a relationship between the numbers in the parentheses and the original thing. So if I look at 25x squared minus 4, well, 5 times 5 is 25. Well, that's because the square root of 25 is 5, and the square root of x squared is x. So I have this 5x, and the square root of 4 is 2. Minus 2, right? And so notice, so these are the square roots of those pieces. So the square root of 25x squared is 5x. The square root of 4 is 2. 5x and 2. 5x and 2 with a sign change in the middle. It turns out that happens because these numbers are perfect squares, right? 1 is a perfect square. 4. So if I look at my square numbers, right? 1 squared is 1, 2 squared is 2, 3 squared is, nope, that's not 2. That is not 2, that is a 4. Oop, my battery's low. All right, right? 5 squared is 25, 7 squared, 49, 9 squared is 81, right? I could go on. You know your squares. Hopefully you know your squares. If not, you have a calculator on your phone, on your tablet, on your computer. You can use Desmos.com, or there's an app for that. So those are where you can get your perfect squares, right? So it turns out that because these are perfect squares and they're subtracted, so I have a difference of squares, right? So if I have something squared minus something else squared, I can factor that to a minus b times a plus b every single time, right? So for example, 100x squared minus 81. Well, the square root of 100 is 10. The square root of 81 is 9. And so that's going to be 10x squared minus 9, 10x squared plus 9. Okay? It works that way every single time. Now, I can do these with the x method, right? So because we did those. So if I want to do 81x squared minus 49, I can do it with the x method. It's going to be messy, right? Because I have to do 81 times negative 49, which, if I calculate that, is negative 3969. That is a huge number. I do not know the square root of that number. Yes, I can use my calculator. Right, and I want to add to 0. So square root of 3969 is 63. So it's going to be negative 63 and 63, and then I got to divide by 81 and simplify. Turns out that it's a whole lot easier just to say the square root of 81 is 9. That's 9x. The square root of 49 is 7. So 9x minus 7, 9x plus 7. Okay? So yes, you can do the difference of squares with X method traditional factoring. But if you remember this nice little pattern, it is definitely handy dandy. So sometimes knowing the pattern is handy dandy. All right, so yes, you can do them with the X method, but if you know the thing there. I am going to attach a practice sheet for you to do on difference of squares. Actually, no, I'm not. There's going to be a delta math. It will not have a lot of problems, right, but it'll say, I can't write today, it'll say difference of squares. Okay, and so you can do that. And then the other thing for you to do is to complete your other factoring stuff if you haven't finished it. And then I will upload one other practice page for you that is identifying A, B, and C from standard form of a quadratic, because we are fixing to do quadratic formula, and that is going to be super duper helpful skill to know how to do. Okay. As always, hit me a message on Canvas if you need help. Send me a message to remind. I'm also considering something else that I think will be kind of neat if I can get enough people willing to do it. So I will post an announcement about that soon in Canvas. All right, guys, until then, stay safe, do well, don't go stir crazy, because I know I am. All right, bye, guys.